Alright, then welcome back everyone. Let's solve this question, desorting. Let me read out the question for you. Call an array A of length n sorted if a1 less than equals to a2 less than equals to so on, an minus 1 less than equals to n. So basically this is the definition of sorted array that they have given in ascending order. Tarsus has an array A of length n, so we are given an array of length n, is allowed to perform one type of operation on it 0 or more number of times. That's important. Operation can be performed 0 number of times. Choose an index I, 1 from 1 to n minus 1. So any index from this 1 till n minus 1, add 1 to a1, a2 till ai, and subtract 1 from ai plus 1, ai plus 2, so on an. So basically if I put, let's say, I equals to 2, the operation is add 1 till this part, a1 till a2, and subtract 1 from a3 till an. That's what this the operation is. Just pick an index, add 1 till that index, inclusive, and for the remaining elements from I plus 1 till the last guy, just subtract 1 from it. Fine. The value of a can be negative after an operation. So any array element can go negative. Fine. So initially I guess the array elements are positive. Right. That's what it is given in the input. Initially array elements are positive. Fine. So determine the minimum number of operations needed to make the array not sorted. Now fine, we are given an array of length n, and this is the operation that we can perform, and we have to find out this is the operation. This entire is an operation. Pick an index, add 1 till that index, and subtract 1 from the remaining part. So determine the minimum number of operations needed to make the array not sorted. So we have to make the array not sorted. Fine. So that is the question, and the input we are given just the array. Now one thing you can easily observe, right? If the initially array was not sorted, you don't need to perform any number of operations, right? So what I'm saying is, if initially the array was not sorted, you don't need to do any number of operation, right? Because they have said you can perform an operation 0 or more number of times. So if you see a test case here, in this case you can see the array is not already sorted, so no operation needs to perform, right? If the array is sorted, then we need to perform some number of operation that we'll see. So yeah, so first observation is clear. If the array is not sorted, anyway you can print 0. So let's just see here. So basically if the array is not sorted, you can anyway print 0, right? You can anyway print 0, no operation need to perform. If the array is sorted, so I've just taken an example here. Let's try to make sense out of it. What should be done? Okay, so if the array is sorted, you know, definitely a1 would be less than equals to a2 less than equals to a3 less than equals to a4. This will happen. Basically here we have 4 elements, so this will be happening. Now to make this array not sorted, what should you do? Basically to make this array not sorted, what should you do? Like, you want to minimize the operation. What is the operation? Basically you have just pick an index. Let's say for example a third index, add 1 to this guys, and subtract 1 from the remaining. So basically you just need to break this equality, right? You just need to break this equality, right? If you can break this any of these equalities, then job will be done, right? So that's what you need to do basically. So decide, like, breaking which equality would be a better thing, equality, or I should say inequality, right? It's an inequality. So yeah, whatever, let's not get too technical here. Basically if I just break any of this inequality, my job will be done. Either if I break this inequality, a1 less than equals to a2, or break this inequality, a2 less than equal to a3, or a3 less than equals to a4, my job will be done. Now since we want to minimize the number of operation, it makes sense that I'll just break any one of these, right? So either these two or these two, right? Because we want to minimize the operation, right? The aim is to minimize the operations. Now breaking which inequality makes much sense, like makes the most sense? Obviously you will break the one in which those two pair of adjacent elements are closest. For example, you can break either this equality by making, let's say, 9 8, so the inequality is broken, something like that. Okay, maybe you can say because in the end what I'm saying is, how can you break this equality is, you can pick I equals to 1 again and again. So if you pick I equals to 1 again and again, what will happen is 1 will be added to this part and 1 will be subtracted from this part. So eventually after some number of operations, this 8 will be less than this 1, and like 1 will be continuously added to this part. So eventually this part, this a1 will become greater than a2. That's what I'm saying. Okay, this 1 will be converted to a bigger number and 8 will be brought down, right? So you're getting what I'm saying. The operation is pick an index, add 1 till that part, and subtract 1 from the remaining part. So basically I can just fixate an index to break an inequality. So what I'm saying is, which one, like which index should you pick? So basically which inequality should you which inequality should you focus on? So my argument is just pick the inequality between the two most closest element. Right? For example, breaking the inequality between 8 and 10 would be easier than breaking the inequality between 1 and 8. Right? Because if you want to break the inequality between 1 and 8, what you need to do is, after one operation, it will become something like this. It will become 1 will be incremented 2, and then 8 will be becoming 7. 10 and 13, I'm not concerned here, and will become 9, okay, and 13 will become 12. But basically, I'm trying to break the inequality between A1 and A2. So after another operation, this will become 3, that will become 6, and rest I'm not concerned, so I'm not writing it. And then so on, this will go. After one more operation, it will become 4, this will become 5, so on. After one more operation, this will become 3, sorry, this will become 5, and this will become 4. So basically, after how many operations? So 1, 2, 3, 4, right? So basically 4 operations. After 4 number of operations, you were able to break this inequality. But instead, if I would have chosen to basically destroy this inequality, it would have taken less steps. So let's see how. After one operation, 8 will become 7 and 10. Okay, 8 will become 9 and 10 will become 9. Rest elements are not concerned. And after one more operation, 8 would have become 8. Sorry, that 9 would have become 10, and then this 9 would have become 8. So the inequality between A2 and A3 broke after just 2 operations. It just broke after 2 operations. That's an interesting thing. So yeah, basically what I'm saying is break the inequality between closest elements. That's what I'm saying. It's very obvious to see that. So the question is, we want to minimize the number of operations. So we have to remove an inequality. So basically remove the inequality between the two closest element, right? So, and how many operations are consumed? That's an interesting thing. So we have agreed upon one thing, that we have to choose, we only need to consider the adjacent elements if the array is sorted. So yeah, by the way guys, we are talking about the case when array is sorted, right? If array is not sorted, then anyway we don't need to do any operation. But if the array is sorted, we just need to break the inequality, any one of these inequalities. And we decided that we have to break the inequality between the closest elements. Then how many number of operations are consumed? This is interesting. So let's see. Let's take an example. Let's say I want to break the inequality between 3 and 7. How many operations are consumed? What is the difference here? The difference is 4, right? So the difference is 4 between them. So how many operations are there? Let's say after one operation, 3 becomes 4, 7 becomes 6. After second operation, it will become 5. This will become 5, and after one more operation, it will become 6, and this will become 4. Okay, it seems like 3 operations here. 3 operations are required here. Let's take one more example then. Let's say this side took 3, 7, right? So maybe 3, let's not take 3, let's say 5 and 10. 5 and 10, or maybe a smaller number, 5, 8. Let's say 5, 8. So after one operation, this will become 6, this will become 7. After one more operation, this will become 7. This 7 will become 6. So just after 2 operations, we were able to break it. So operations consumed were 2. Okay, the difference was, what was the difference here, by the way? The difference was 3. Okay, so you can see one thing here, from this, if the difference were 4, the operations were 3. If the difference were 3, the operations were 2. Okay, so you can take some more examples, but the formula that you will get here is, again, see guys, I'm not remembering any formulas here, but if you're just tracing out the examples, you can observe one thing. If you have a if the difference between the closest pair is actually equals to, let's say, diff, okay, then the operations that you need to perform is diff by 2 plus 1. Okay, so this is what you need to do. For example, here 4 by 2 plus 1, here 3 by 2 is 1 plus 1 2, right? So that's what you need to do. So this formula, like, I didn't remember it, I just figured out on the fly. So maybe you can take 2 or more examples, and then you'll get it. So yeah, because in one operation, basically what is happening is, why this formula makes sense is, in one operation what is happening is, one element there is a change of 2, that's why this 2 is coming, right? In one operation, this A2 gets incremented and A3 gets decremented. So there's a change of 2, that's why if we have a difference between two elements diff, then diff by 2. So yeah, and the formula, figuring out the formula is not a big deal, so this can be done out. The main idea was that we have to break the inequality between the closest element, and if the difference is diff, then the operations are diff by 2 plus 1. So that was the main idea, right? So let's just quickly code up the solution then. So first we have the array size, then I'll take the array input, current equals to 0, I'll just and n I plus plus c in array of I. I think the constraints were less, so I can store everything in an integer. Now, first things first. If array is already sorted, right? So if array is not sorted, basically, if array is not sorted, then anyway there are no operations consumed, so I can just print 0 followed by new line. Okay, but if the array is sorted, we need to pick the closest pair. Basically, we just need to go through the we have to find out an adjacent pair which is closest, right? So we need to find out the diff between the closest pair of adjacent elements. So I'll just initialize diff to maybe 0, right? Because all elements are positive. So initially I'm assuming that diff is 0, and okay, not 0, right? I'll have to take a very big value, let's say 1e9. Initially I'm assuming a diff to a very big value because I want to find out the minimum difference, right? So initially it will be a very big value. Let's go through the entire array. Maybe I can take 1e10 because their elements were I guess, yeah, 1e9. So yeah, maybe I'll just take 1e10. So 1e10 fits in an integer, is it? Let's be safe here. Let's pick into max only. Let's not risk anything here. So yeah, 1e9 usually, 1e10 I don't know. Okay, fine. So we have to find the closest difference, minimum difference basically. So I'll go from first I less than n I plus plus. So usually in CP you should not take, you have to be very sure, you should not take risks, because one wrong submission and you will lose a lot of, there will be a penalty, right? So yeah, that's that. So now you are sure that array is sorted, so you can do minimum of diff and array of I minus array of I minus 1. So why I don't need an absolute value here? Because I am sure the array is sorted. So array of I will be greater than array of I minus 1. So we found the minimum difference, and what are the operations? You can calculate the operations. It's basically diff by 2 plus 1, right? So cool. So why diff by 2 plus 1? We've just seen the examples. Maybe you can trace out some more examples for your convenience, but this should be it. Right, so array input, if array is not sorted, if array is already not sorted, then we don't need to do any operations, everything is good. Otherwise, find out the minimum difference, find out the pair which is closest, find out the adjacent pair which is closest, and if the difference is diff between both of them, then the operations consumed will be diff by 2 plus 1. Right, so yeah, let me just print it. 1203 should come, right? I'll just remove this. 1203, yeah, fine, so it works. Let me just quickly submit it and see if it works. Should work. Yeah, it works. Maybe I'll just go back and yeah, it works. Alright, then thank you for watching. I'll see you in the next one.